question, we are recording the motion of this cart along this track using a motion detector. We're also going to be measuring the force that this cart has on that force device. And then we're going to use these two to create graphs on the computer that will look something like this. And with these graphs, we'll determine the cart's average acceleration, the magnitude of the change in the car's momentum, the mass of the cart, and the energy lost. So we'll start with going over finding average acceleration.
Do you want to hold the thingy?
Yeah.
So the experiment's pretty simple. You start collecting data on the computer, sort of like start the process, hit a button, and you push the cart. So as the cart's moving, this motion detector is going to sense how far and how fast the cart is moving away. So it'll tell us its velocity as it moves. And when it hits the force sensor and bounces back, that's going to give us a reading of the average force while the cart is in contact with the sensor. So we can do it right now.
And then we can show them the screen too.
That's
while
it.
we do it.
So when you get the data, it looks something like this. So up top is what the force sensor read. So here's when the cart's moving, and then right there, that spike is when it hits the sensor, and that's when it's at the biggest force. This is the cart's position. We don't have to worry about that one. And this is its velocity. So cart's moving along, and this sharp decrease right here is when it's hitting the force sensor, and the velocity is negative below here. So that's when it's rolling back towards the motion sensor at the other end. So if we want to find the average acceleration, we can look back at this velocity graph, and acceleration is the derivative of velocity, or it's the slope of the line on a velocity graph. So if we're looking at the average acceleration when the cart is hitting a force sensor, we look at when it starts to hit the force sensor, which is when the velocity starts to go down, and when it stops, which is when the velocity is constant, going the other way. So if we look in this interval and find the slope between those 2 points, that'll be the average acceleration. And we did that math, and it comes out to be negative 3.433 meters per second squared.
Part B of this question asks to determine the magnitude of the change in the cart's momentum during the collision. And a change in momentum is also known as impulse. And to find that, you take your force graph, which you find when the cart hits the force detector. You get a spike in the force, and when we ran our experiment, we found that the time interval was between 2.8 and 3.1 seconds. And once you have your force graph, you just take the integral, which is the area under the graph of the force, which will then give you your change in momentum, and we found that to be 0.2603.
Now on part C, or question, we just found the integral of the force time graph, which equals impulse, which equals change in momentum. So part C asks us to find the mass of the cart. And we can use this integral to find that. So 0.2603 equals the change in momentum, delta P, which equals mv final of the cart when it's moving back from the force sensor minus mv initial. So we can keep this going. 0.2603 equals the mass of the cart, factor that out, so this equation, the final velocity minus the initial velocity. And looking at our graph like this, the velocity graph, the final velocity of the cart as it's moving back is negative 0.5 meters per second, and its initial velocity is 0.65 meters per second. So if we plug these numbers into this equation and divide both sides by v final minus v initial, that'll cancel out, and then this equals the mass. So if we plug those numbers in, we get that the mass is 0.253 kilograms, the mass of the cart.
Yay.
So we're back with part D of this question. This was part B, finding the change in momentum, which is the integral of the force-time graph, and part C, which is finding the mass of the cart. So now part D says determine the energy lost in the collision between the force sensor and the cart. So to do that, we can start with this equation, delta E, the change in energy, so the energy lost from the initial amount to the final amount, equals the change in kinetic energy. And we know that kinetic energy is 1/2 mv squared. So we can go, change in energy is 1/2 the mass of the cart times the final velocity of the cart squared minus 1/2 the mass of the cart, the initial velocity of the cart squared. And we know, we just found mass in part C, and we know the final velocity, and we know the initial velocity from down here. So if we plug all those numbers in, these are all known values, we get that the total energy of the system went down by 0.0352 joules, so it lost that much energy.